So I'm working on the text-to-speech module again. Just a quick overcap here. We've got an arduino nano running some custom software that uses PWM and modifying of PWM, which is essentially making variable variations and vibrations on the speaker to imitate the sounds of a voice. And we went over all that in a previous video, so I'm not going to recap all that. You can go watch that video. Some changes I've made here is I added an LED for visual indication of when the board is speaking, and it seems to be timed pretty well with it. Now I've got it working over I2C, so on crash I just took and added a simple line on him. You can see everything else is still doing what it's supposed to do. He's pissed off because I've been ignoring him for over an hour now, and he's just been sitting here doing nothing. But I've got a jumper set here for the I2C bus. The I2C is the inner circuit exchange that allows chips to talk to each other. It's used for all kinds of things like the LCD, and the compass connects through that, as well as the gyroscope and the ESP and the serial wombat, which lets us talk to the sound effects board, and the servo controller. So it's kind of an important thing, but you can stack a bunch of devices on this bus before you start having issues, and it's great because I've only got like 5 or 6 on there, I think, right now. So because this has the ability to do I2C as well, I made it an I2C device, so it's its own standalone unit, just like if you were to plug in a gyro that was I2C, or the compass that was I2C. The ESP32 main processor can now address it with the address 0x08 on the bus. And then what it does is, right now I just have it counting, so it starts at 0, it counts up to 255, and then it starts over. And you'll see that in the debug window. This is what this is receiving from the bus. And then I just wrote a few quick switch statements here based on the received number that's sent. So what we'll do is we have all these bits of language that we can have him say now. So we'll assign a number to each of those words, right? And then what we'll do is we'll send that corresponding number over the bus to this, where it will trigger one of the responses. You can see time is, when it says 0, okay to 25, thank you, it's 65. And now it won't normally count. We'll send this number to this device only when we want it to talk, and it'll say what we want it to say. The bus can do 255 numbers, including 0, which means there's 256 options to use, and we've only got 60 phrases, give or take a couple. So there's plenty of command numbers to use as well. So if you listen, when it hits those numbers, it'll say the word corresponding to that number. And if you watch this, the LED lights up when it talks. So the only thing I have left to build on this is the audio amplifier, so that this is something you can actually hear. And I gotta find a different speaker because I don't like this one. I might have another one of these floating around, I don't know. I'm really gonna have to dig. I was also considering playing with using the second channel on the sound effect board, because I only use one. I don't use, what is it, the right channel or the left channel, I forget which, for my sound effects. So I might piggyback through its amplifier to make this louder. That could be something fun to play with. But this is, as far as it is right now, this is ready to go on a circuit board and get installed. And we're probably going to install it on this side of the chassis back here, out of the way, like we did with the sound effects board, where it's back out of the way. At least for now. They may end up both getting installed up inside the chest here, because I got a lot of room back up in here with nothing in there. So we'll see where we end up putting the board. But yeah, it's a fully functional I2C device that can be interfaced, and commands can be sent to it, and it'll say whatever you want it to say based on the command sent. I just have to go through and write 256 lines of switch statement, which overall isn't really bad when you consider that his main operating system has, that's this file here, and it's I mean, it's probably well over 1,000 lines. So another 200 is nothing, and it's simple stuff. It's just drone work, really, because it's, you know, case 1, case 2, case 3, case 4, case 5. Really, it'll go quick, so what I'll do is I'll copy one line, and then I'll paste it and 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 paste it until I have 256 of them, and then I'll just go through and manually key in each number. So it'll be quick, take maybe 20-30 minutes to do that. But yeah, he can talk now. So